Today's lesson is on 4.5, isosceles and equilateral triangles. So the first thing we need to do is define an isosceles triangle. An isosceles triangle is a triangle with two congruent sides. Now let's go through all the different vocabulary we need for isosceles triangles. I'm going to draw one here. The legs are the congruent sides of the isosceles triangle, and in that diagram over there, the legs are in red. The base, which is in green over there, is that third side of the isosceles triangle that isn't congruent to the other two. The vertex angle, which is in blue in that diagram, is the angle included between the legs. And then finally, the base angles are angles that are touching the base side. So there's the vocabulary we need for isosceles triangles. Now we have an isosceles triangle theorem, which tells me that if two sides of an isosceles triangle are congruent, in this example I have if side AC is congruent to side BC, if that's the case, then those base angles are also congruent. In this case, angle A is congruent to angle B. And so in English, that means that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. Okay. There is our isosceles triangle theorem. The converse of that is also true. So in our isosceles triangle theorem, we said if the sides are congruent, then the angles are congruent. So in the converse of that, we're going to say, well, if those base angles of a triangle are congruent, then the sides are congruent. Or if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So either way, if the two sides are congruent, then the base angles are congruent. If the base angles are congruent, then the legs are congruent. All right, so based on that, we can do two example problems. You should pause the video and try these example problems. I'm just going to go through them right now. So you should pause it and then come back when you're done. Okay, the first one is asking, is AB congruent to CB? Well, the answer is yes. And how do we know that? Well, because angle A is congruent to angle C. So this is the converse of the theorem. If those two angles are congruent, then the sides opposite those angles are congruent. So in that case, it would be AB is congruent to CB. The second question it's asking us is angle A congruent to angle DEA? And again, oh, I'm sorry, that one, the last one we just did was, again, if two angles of a triangle are congruent, then the sides opposite those angles are congruent. That's what we just learned. All right. For the next one, the answer is going to be yes for the converse of that reason. And the reason why is because we know that AD and DE, or AD and ED, are congruent. It says so on our diagram. If that's the case, then angle A is congruent to angle DEA. And the reason would be because if two sides of a triangle are congruent, then the angles opposite those are congruent. Next, I want to go over the vertex angle of isosceles triangle bisected, what that means. So what that means is that if I have an isosceles triangle, so in this case, AC is congruent to BC, and I bisect that vertex angle, so C is my vertex angle, and I bisect it, so ACD is congruent to BCD. If that's the case, then CD is parallel to AB, and AD is congruent to BC. So in other words, CD is both perpendicular to AB and it's the bisector of AB, so it is the perpendicular bisector. So in English, if a line bisects the vertex angle of an isosceles triangle, then that line is also the perpendicular bisector of the base. Okay. So based on that, we can now find the value of x here. How would we do that? Well, first, again, if two sides of a triangle are congruent, then the angles opposite those sides are congruent. Okay, well, in this case, we know that BA and CB are congruent, therefore angle A is congruent to angle C. And since angle A is 54 degrees and they're congruent, then the measure of both of them must be 54. So now I have C is 54. And since ABD is congruent to CBD, that means that BD bisects ABC, which therefore, as we just learned, means it's the perpendicular bisector, because if a line bisects the vertex angle of an isosceles triangle, then the line is also the perpendicular bisector of the base. So therefore, BD is perpendicular to AC, which means that both of those angles, ADB and CDB, because those lines are perpendicular, are both 90 degrees. And since we also know that any three angles of a triangle add up to be 180, we know that in that triangle on top, we have BDC, I'm sorry, the triangle on the bottom, excuse me, BDC and DCB and CBD are those are the three angles of our triangle at the bottom, and those equal 180. And now I can just substitute values in, because I know that BDC, as we said above, is 90, and angle C, as we said above, is 54. Therefore, angle X, which is angle BDC, is add those three together and it's 180. So therefore, if I do that out, X equals 36. Okay. We've talked about isosceles triangles. Now let's talk about equilateral triangles. An equilateral triangle is a triangle whose sides are all congruent. So all three sides, AB, BC, and AC, are all congruent to each other. An additional thing about an equilateral triangle, first, before we do that, we have to tell you what an equiangular triangle is. And an equiangular triangle is a triangle where all the angles are congruent. So equilateral is the sides are congruent, and equiangular is where the angles are congruent. And it turns out that those are actually the same thing. So that if a triangle is equilateral, then it is equiangular, and the converse is also true. If a triangle is equiangular, then it is also equilateral. So if I know the three sides of a triangle are congruent, that I know its three angles are congruent, and conversely, I know if its three angles are congruent, then I know that its three sides are congruent. So this problem is asking us to find the measures of M and N. Okay, so for M, I notice that in that triangle over there, triangle ACD, AD and AC are congruent. Therefore, it's an isosceles triangle. Therefore, the base angles are congruent. So ADC and ACD are congruent, and ACD is M. And therefore, if ADC is 45 degrees, as it's shown there, then M must also be 45 degrees. So we found M. To find N, I notice that in triangle ABC, AB and BC are congruent. So those must be congruent sides. Then the base angles are congruent. So BAC and BCA must be congruent. And since the three angles of a triangle add up to 180, then those two angles that I just talked about, plus the one at the top, ABC, must equal 180. And so let's just say that, let's call both of those x, then x plus the angle ABC equals 180. And we know that ABC is 60, so I can just substitute that in. Subtract 60 out, and I've got 2x is 120, or x is 60. So therefore, I know that M plus N, those two together, are going to equal 60 degrees. And if they equal 60 degrees and M is 45, then N must be 15. So that first triangle over on the left, ACD is an isosceles triangle, and I take advantage of that fact to notice that the two base angles are congruent. And then that second triangle, ABC, I can prove it is an equal angular triangle, so it's an equilateral triangle. And if they all add up to 180, then I can figure out how big BCA is, and then subtract out M to find N. The final question I want to go over today is asking us in example 4, what are the measures of angle A, B, and ADC? And I can tell from looking at this diagram here that this is actually 3 different equilateral or equiangular triangles. They're equilateral because they have the same markings on them. So I know that all of those sides, AD, DE, and AE, are congruent. So the triangle on the far left is a equilateral triangle. The triangle in the middle, because CD, DE, and EC are all congruent, then triangle CDE is an equilateral triangle. And BC, CE, and EB are all congruent. Again, they all have the same marks, so they must all be equilateral. That must be an equilateral triangle too. And if it's equilateral, then it's equiangular. And if they're 180 degrees in a triangle, then each of these angles in an equiangular triangle must be 1/3 of that, or 60. Okay? So all 3 of these triangles are equilateral because the 3 sides are measured. Therefore, they're all equiangular, because if it is equilateral, then it's equiangular. Okay? Therefore, angle A is 60 degrees, as we said, because 60 plus 60 plus 60 is 180. So for all equiangular triangles, it's a 60, 60, 60 triangle. So angle A and angle B there are both parts of equilateral triangles, so it must be 60. The third one it's asking me for is angle ADC. And through our angle addition theorem, we know that angle ADC is equal to ADE plus EDC. And we know that both of those is 60. So if I add them up together, I get 120. So the measure of angle ADC is 120.